Hello and good day, or if you're an ATC, howdy and good day. We're going to start by correcting CO12. We really only have the last two to do for homework. And the whole gist of this concept, the practicality of it, like we talked about, isn't very high. Normally, when you're in this type of situation, you'd probably plug in the values and solve for the missing one. But as we discussed, the ability to manipulate an equation is something that's going to come back later on in graphing and systems and parabolas. And the seeds that we're planting now will be helpful when that day comes. So for this circumference of a circle, it can be found with the formula C equals pi times the diameter. Write a formula to solve for D. And what is it when the circumference is 26 feet? So like we talked about, the process to solve an equation like this is the same as if we had numbers, okay? What are you doing to the variable? You're dividing by pi. Sorry, you're multiplying by pi. So the opposite of that, to undo it, you're going to divide both sides by pi. Okay? On the right side, they cancel out, which is exactly what we want to happen. And so our equation is C divided by pi equals D, meaning that the circumference of any circle divided by pi will equal the diameter. And it makes sense because if the circumference is equal to the diameter times pi, then the circumference divided by pi is going to equal the diameter. And so when we have a given value of 26 divided by pi, what do you come up with? About 8.3. Okay, good. 8.2, fine. It depends on how you round this up. What value you use for pi? Yeah. Question? Yes.
Oh, I got 8.28.
8.28, fine. Okay. The last one here. Albert Einstein is well known for his discovery of the formula E equals mc squared, which this is eerily similar to what other formula that we worked with yesterday. E equals mc squared, eerily similar to, Lauren, A equals pi r squared. In fact, the process to do this last one here is the same thing as we did for the circle question. You've got E, which is equal to something times something squared, right? Pi times r squared, m times c squared. Doesn't matter what the variables are. What are we doing to c? We're squaring it, and then we're multiplying it by m. So to undo that, we're going to start by dividing both sides by m to, on the right side, cancel them out. And that gives us E divided by m equals c squared. And of course, the opposite of squaring something is rooting something. So we're going to root both sides. Those operations cancel out. And we're left with the square root of E divided by m equals c. So in context here, if E is 150 and m is 6, then we have the square root of 150 divided by 6, and that's going to equal c. Well, what's 150 divided by 6?
5.
Well, 25, but then the root of 25, the root of that will equal c, and that's how we get c to be 5. Okay? So your objective on the test for this is going to be pretty elementary, because we didn't spend a ton of time on it, and you didn't have a lot of practice with it as far as homework goes. But the point of this was just plant those seeds of equation manipulation so that when we get to it later on, you're not learning two things at once. You already kind of have this background knowledge. Okay? Any questions, comments, concerns, complaints, comments, congratulations, or criticisms on that? No. Onward and forward we go to CO13 then. Inequalities. What is the difference? We'll jump right in. What is the difference between an equation and an inequality as far as what their purpose is or their function? What does an equation do, Elise? Okay, so the equal sign literally means the same as. Okay, so an equation compares values that are the same. Okay? And the equation compares values that are the same. And so in inequality, Gabby, compares values that are not the same. And if we're comparing values that are not the same, that kind of brings up a whole slew more options, right? And that's why we have 4 symbols for inequalities versus just 1 symbol for an equation. Daniel, you have a question? Oh, okay. So the 4 symbols for inequalities, we've got one that looks like this, one that looks like that, one that's kind of a hybrid of the less than sign and equal sign, and then one that this again, yes. So this first symbol here, what do we call that one? Less than, right? Less than. And probably, the hardest part about this is remembering which one's less than, which one's greater than. No doubt you've heard of the analogies of the alligator eating the larger number or the symbol pointing to the smaller one. Growing up, I always used the L trick. It's an L squoosh down is the less than symbol. And then the other one's just a greater than symbol. I had one year someone trying to convince me that the greater than symbol looks like a G. I don't know. I think that I don't see it, but whatever. So whatever you want to use is fine as long as you can tell the difference between them. And you're familiar with the second 2 also? Less than or equal to? And greater than or equal to? Okay. Less than or equal to and greater than or equal to. I'm going to redraw that less than sign. That was kind of So what can you tell me about the graphs of these 4 types? When you graph these solutions on a number line, what do they look like? Elise? Yeah, 2 of them have an open circle and 2 of them have a closed circle. Which ones are open and why? Debbie? Actually, the less than or equal to and the greater than or equal to will have a closed circle because it includes kind of the number that we care about. That includes that target value. So let's just kind of go down this first one here. Burning at least 400 calories. Just look at the graph of that. Okay, burning at least 400 calories. First of all, which symbol does at least refer to? Brent?
Greater than or equal.
Very good. It's kind of tricky because you see the word least and you might think less than, but if you're saying at least 400 calories, that means you want 400 calories or more, right? So the phrase at least belongs with greater than or equal to. And if 400 is included in that, at least 400 is a part of it, we want that closed circle to show that 400 is a solution of this, as is every number to the right of 400. Okay? So the graph of a greater than or equal to situation will be a closed circle going to the right. Number included and everything else greater than it. So less than or equal to is going to have a closed circle going left. Okay? And it's the less than and greater than symbols that have open circles because the number is not included in the solution. Okay. What other phrases you see on this page would apply with each of the 4 symbols here? We're doing the same thing that we kind of did with equations before in the 4 operations. What phrases would you translate to symbols. Gabby. Most is what? So for the second one, the most you can spend at the store is $20. You said less than or equal to? Okay, that would be correct. The most you can spend is 20. That means you can spend 20, but that's it. That's the maximum. Okay? Maximum is another phrase that would belong under less than or equal to, right? The maximum weight on the elevator is 2,000 pounds. Better stay 2,000 pounds or below. So what word kind of goes along with maximum, kind of the opposite of maximum? That would be under the greater than or equal to symbol. Minimum. What do British people call their short moms?
Midgets.
Minimums. Okay. Other phrases, maybe focusing on the less than, greater than. Lucas. No more than. What would that fall under? Less than or equal to. Here's another one. We'll add it down here. No more than. But just more than by itself would be greater than, right? So more than just by itself is greater than, but no more than is going to be less than or equal to. Others. There's one other one on here for sure that will go under the less than. Yes, less than definitely would be less than. Yeah. Fewer. Okay. Fewer than 8 strokes to win the tournament. That means if you get 8, you didn't win. You're probably tied. Okay. But you need fewer than that, and so it's going to be less than. 8 would not be included. Okay. So your task is to look at each situation and write the inequality 2 ways. So when we say burning at least 400 calories, we've already said that the number of calories that we want to burn is greater than or equal to 400. Okay, 400 is part of it, and anything greater than that. What's the other way to write this inequality? Picked on you. Not the graph of it, but the other way to write this statement. Elise? Very, very good. Yeah. If C is greater than or equal to 400, then the relationship between 400 and C, 400 is going to be less than or equal to C. So when you reverse the variable and our target number, our solution number, the inequality sign must also flip. And we see why that works when we graph this, right? When we graph this, we've got a number line here, and I don't know how you did it last year and years past. If you want to keep it that way, great. If you want to adopt this, great. Maybe they're the same. I don't know. But on a number line, we aren't going to plot every number, right? We're only going to put the 400 because that's really the one that we care about. Okay? 400 is that kind of solution point. Above the 400, because it's included, and it's a greater than or equal to symbol, we've got the closed circle to show that 400 is part of this. And then everything to the right. And you can use an arrow to point that direction. If you want to shade it, that's fantastic, whatever you want to do. Just to show that the numbers that are part of this solution are 400 and everything greater than that. Okay? Someone pick a number that's in that solution set. Greater than or equal to 400. 401. Okay. So 401, okay, part of that solution set. If we plug that in for C in our first inequality up here, is 401 greater than or equal to 400? Yes. Okay. That also works in our second one. Is 400 less than or equal to 401? Yes. So even though there are 2 ways to write that inequality, the graph is still going to look the same. Okay? The graph is still going to look the same. Every number to the right of 400 is going to work. Every number to the left of 400 is not going to work. The most you can spend at the store is 20 bucks. Give me a way to write that inequality. The most you can spend at the store is 20 bucks. Bridget.
20 less than or equal to us, or spend money and.
Well, you can write it either way, right? You can either write it with the money first, or you can write it with the 20 first. What's going to be different is your inequality symbol. So let's compare M with 20 first. Okay? The most you can spend at the store is $20, which means the money that you can spend at the store, that's what our M is going to represent. What's the relationship between M and 20? Is it going to be above 20, 20 and above, or is it going to be 20 and below? 20 and below, which is going to be the less than or equal to symbol. I know. Yeah. Okay. But then we can flip that around and say, well, if the money you can spend is less than or equal to 20, that means 20 is greater than or equal to the amount of money you can spend. Both of those inequalities say the same thing. But the graph is the same for both of them regardless. 20 is our solution number, what we care about. It's going to be a closed circle going to the left. Okay. Now, does anybody see a potential problem with the context of the situation and the graph that we've made here? This is called foreshadowing, what would be coming up a little bit later on. Noah, is that a hand up or just stretching? Go ahead.
We don't know what zero is.
Sorry?
We don't know which side the zero is on?
Well, we know where 0 is, right? 0 is on the left side of 20 because it's less than that. But it does have to do with 0. Daniel? Oh, okay, we could possibly, but we would have to include tax. If all we have is 20 bucks to spend, we'd have to include tax in that. So 20 is still the maximum. Gabby? Right. We run into a problem here that if we say that any number less than 20 is a solution to this, what happens when we get to 0? Is negative 1 make sense?
Yeah, because then you make money.
I've never gone to Target and made money, ever. Ever have I done that. If there's a way to walk into Target and come out with more money than I have when I started, you let me know, because I'll be all over that. Rob the store. Okay, that was Brady, just for the record. So no, but we run into a bit of a problem. I mean, is negative 1 a solution to M is less than or equal to 20? Yes, negative 1 is less than or equal to 20. But in the context of the question, would negative 1 make any sense? No. So this is, like I said, this is kind of foreshadowing something's coming up. In CO13, we will talk about compound inequalities. And what compound inequalities do, and it sounds like you have some experience with them, is they more adequately address context in situations such as this, to where, yes, there's a maximum we can spend, 20 bucks, but there's also a minimum, right? You can spend 0, even though I've also never done that, walk on Target and spend nothing, right? But you can't spend less than 0. So anyway, but for right now, this is what we're looking at here, just the standard graph there. Any others on this page that you want to go over? They will be, yes, but not due until Thursday, because tomorrow is your retake day. So you got a couple days. All right, on the second page then. What? I heard a wait. Yes. You must be 18 or older to vote. We don't have any phrases like this up in our chart up there, but just think about this. You must be 18 or older to vote. The age that you need to be to vote, what's the relationship with your age and 18? Is your age less than 18?
Greater.
Is it greater than? Is it greater than or equal to? Or just greater than?
Greater than
greater than or equal to, right? Because it says 18 or older. That word or is a little bit of a hint. That's going to be that greater than or equal to. So the other way to write this, if your age has to be greater than or equal to 18, that means 18 has to be less than or equal to your age. If you're 40, 40 is greater than or equal to 18, 18 is less than or equal to 40. It works in each of them. Graphing this, we again are going to have a closed circle above 18 and going to the right. 18 and anything older than that.
Will that be on the test?
Yes, your test is going to be, I think, just 4 of these where you have to write.
I mean, like
oh,
the 18 or older,
it might be. I don't remember exactly the phrases used on the test. But even if you just kind of think about it, so if I'm 19, can I vote? Yes.
Yeah.
What if I'm 18? Is that included? 18 or older? Yes. So even though it's not in the chart, or if I don't use that phrase specifically, you can just think about the situation and see what values work, what values don't, and you can go at it that way too. On the second page then, we start with 4 very similar to the front side. The difference is that all 4 of these kind of have to deal with the same thing, using the words colder and warmer, negative 25 degrees or colder, negative 10 degrees or warmer. Each of the 4 inequality symbols is used once. And just like before, write the inequality 2 ways and then graph it on the number line. And then at the bottom, I give you 4 graphs. And so your job here is to interpret the graph and write the inequality 2 ways. So we'll take the first one. I don't know how well this shows up on your page, so if it doesn't show up great, I apologize. But we look at this here. What inequality symbol are we going to have? Less than, greater than, less than or equal to, greater than or equal to. Well, yeah, so our solution is 11. We'll just use n. You can use any variable you want to. But what symbol is going to go in between there? What does this graph tell us? Gabby? Greater than. It's open circle, and it's going to the right. So the open circle tells you it's either less than or greater than only, not the or equal to stuff, right? And it's going to the right, which means it's going to be greater than. So the two clues are what type of circle and which direction is it going. And if n is if n is greater than 11, that means that 11 is less than n. And again, you can pick a number in this set and make sure it works. 14. Is 14 greater than 11? Yep. Is 11 less than 14? Yep. So it checks out. Erica.
Can I use any variable?
Yes, you can use any variable you want. Okay. Anything else with this?
No.
Okay. So, no homework due tomorrow. This will be due Thursday. Use the evening to prepare any practice work that you might have. The question was asked yesterday, can geometry retakes be taken during algebra time tomorrow if you don't have any algebra ones? The answer is yes. That is fine with me. Otherwise, you've got Khan Academy due Thursday. If you want to work on that tomorrow during class, that's fine too. Lots of options to consider.
Can I ask a question?
Yes, you may ask a question.
Why did you make the Khan Academy so hard?
Is it hard this week?
I did like
Is it? I don't know.
all of them.
If you have a question on some of them, I don't remember, to be honest, off the top of my head what I assigned.
We were all struggling that day when you did.
Really? Oh.
Yeah. You should just take it out completely.
Do you want to take a look at it?
No.
I can go over a couple of them. Okay, let's stop recording, and then those who want to talk about Khan, we can talk about Khan. So, question or stretching?
No.
Excellent. That's how you math.